Imagine wearing something so simple that you barely notice it. Yet behind it lies a manufacturing journey that stretches across continents. A tiny wristband might cost only a few dollars, but creating it requires precision engineering, chemistry, massive factories, and thousands of skilled hands. Think about this. Every year, billions of wristbands travel from factories to concerts, hospitals, amusement parks, sporting events, and even space research facilities. But here's what nobody tells you. The story begins deep beneath the Earth's surface, long before the first band ever wraps around a wrist. You see a finished wristband as a lightweight accessory, but manufacturers see a masterpiece of materials science. Some wristbands must survive freezing temperatures, while others resist sweat, sunlight, chemicals, and thousands of stretches without breaking. Hospitals depend on them for patient identification, while music festivals trust them to control access for tens of thousands of people. And this is where our factory journey truly begins. Next comes one of the most dramatic stages: compression molding. Hydraulic presses close with forces reaching 100 to 200 tons, squeezing the silicone into precision steel molds. Inside the mold, temperatures typically reach about 170 degrees Celsius to 190 degrees Celsius, or 338 degrees Fahrenheit to 374 degrees Fahrenheit, while curing takes roughly 60 to 180 seconds, depending on the design. As the press opens, perfectly formed wristbands appear almost like magic. For silicone wristbands, the journey begins with quartz, one of Earth's most common minerals. Huge mines in China, the United States, Brazil, and Norway extract millions of tons of high-purity quartz every year. The rock contains over 99% silicon dioxide, but transforming it into usable silicon demands enormous electric furnaces reaching nearly 2,000 degrees Celsius, or about 3,630 degrees Fahrenheit. Inside those furnaces, bright white heat glows so intensely it almost looks like liquid sunlight. Factories combine purified silicon with oxygen, carbon, and carefully controlled chemical compounds to create flexible silicone polymers. Every batch undergoes laboratory testing because even tiny impurities can weaken the final product. Imagine technicians wearing white protective suits, carefully measuring ingredients accurate to fractions of a gram. The smell of warm chemicals fills the air while mixing machines quietly prepare the foundation of billions of wristbands. Fabric wristbands begin thousands of kilometers away inside giant petrochemical plants. Crude oil and natural gas become polyester pellets through carefully controlled chemical reactions before those pellets melt into incredibly fine threads. Each thread measures only a tiny fraction of a millimeter thick, yet together they become strong enough to survive rain, sunlight, and weeks of constant wear. You can actually hear the rhythmic hum of spinning machines echo across the enormous production hall. For premium leather wristbands, manufacturers carefully source hides from certified tanneries in Italy, Brazil, and Argentina. Skilled workers inspect every surface for scratches, scars, or natural imperfections before the leather enters environmentally controlled tanning facilities. Modern vegetable tanning can take several weeks, while advanced chrome tanning finishes much faster under tightly monitored conditions. The rich scent of fresh leather mixes with the sounds of cutting presses and polishing wheels. Color may seem like the easiest part, but creating a perfectly consistent shade challenges even the best chemical engineers. Pigments arrive from specialized manufacturers in Germany, Japan, South Korea, and the United States, where laboratories measure every batch for color accuracy. A difference almost invisible to the human eye can cause an entire production run to fail quality standards. That means thousands of wristbands could disappear before anyone outside the factory ever sees them. Hidden inside many modern wristbands lies technology smaller than your fingernail. Tiny RFID and NFC chips come from semiconductor factories in Taiwan, South Korea, Japan, and Europe, where ultra-clean rooms remove nearly every dust particle from the air. Robotic arms place microscopic electronic components with astonishing precision measured in microns. One invisible speck of dust can ruin an entire electronic chip. Before any material reaches the wristband factory, ships, trains, trucks, and cargo aircraft carry it across oceans and continents. Some shipments travel more than 10,000 kilometers, crossing multiple borders before arriving exactly on schedule. Imagine thousands of containers stacked at giant ports, each carrying just one small piece of the final product. But the biggest transformation hasn't even started yet. Now every ingredient has arrived, every machine stands ready, and every engineer waits beside glowing production lines. In just a few moments, heat, pressure, chemistry, and precision automation will turn these ordinary raw materials into millions of perfectly engineered wristbands. And what happens inside that factory is far more extraordinary than most people could ever imagine. The moment the raw materials enter the production floor, everything changes. Conveyor belts glide forward with perfect timing, robotic feeders dispense measured batches, and digital control panels monitor every movement in real time. Imagine standing beside the line as motors hum, warning lights flash, and warm air carries the faint smell of heated silicone. Every second counts because even the smallest mistake can affect thousands of wristbands. 4 silicone wristbands. Giant mixers combine silicone rubber, curing agents, and color pigments into a perfectly uniform compound. The heavy blades rotate at around 40 to 60 revolutions per minute for 15 to 20 minutes, folding every ingredient together until no streaks remain. The mixture becomes smooth, flexible, and almost dough-like. Workers inspect its texture because experience can spot tiny problems before any machine does. Next comes one of the most dramatic stages: compression molding. Hydraulic presses close with forces reaching 100 to 200 tons, squeezing the silicone into precision steel molds. Inside the mold, temperatures typically reach about 170 degrees Celsius to 190 degrees Celsius, or 338 degrees Fahrenheit to 374 degrees Fahrenheit, while curing takes roughly 60 to 180 seconds, depending on the design. As the press opens, perfectly formed wristbands appear almost like magic. But here's what nobody tells you: the wristbands still aren't finished. Freshly molded pieces carry tiny flashes of excess material around their edges. Precision trimming machines remove these thin lines in seconds, while skilled operators inspect every band under bright lights. You can hear the soft click of cutters and the steady rhythm of automated trimming systems filling the factory. Printing begins only after every surface passes inspection. High-speed screen printing and pad printing machines apply logos, slogans, and artwork with incredible accuracy. Some production lines print more than 2,000 wristbands every hour, while UV-curable inks harden within seconds under brilliant ultraviolet lamps. The smell of fresh ink mixes with the gentle warmth of the curing system. Fabric wristbands follow a completely different path. Computer-controlled weaving machines interlace thousands of polyester threads at remarkable speed, creating detailed patterns directly into the fabric instead of printing them on top. Every movement happens with microscopic precision as hundreds of threads dance together in perfect synchronization. The constant mechanical rhythm sounds almost like music inside the weaving hall. After weaving, powerful laser cutters slice each wristband to its exact length with astonishing precision. Focused laser beams instantly seal the fabric edges, preventing fraying without touching the material. Bright flashes appear for only a fraction of a second before another perfectly cut wristband moves down the conveyor. What seems effortless actually depends on years of engineering. RFID wristbands add another layer of complexity. Tiny electronic chips slide into specially designed pockets or become permanently embedded during molding. Automated systems verify every chip before sealing it inside the wristband, ensuring it communicates perfectly with scanners. Imagine millions of invisible digital identities being created every single day. Now the production line reaches its fastest pace. Conveyor systems move hundreds of wristbands every minute as robotic arms sort them by color, size, and customer order. Barcode scanners track every batch automatically, allowing manufacturers to trace each wristband back to its raw materials. Nothing disappears, and nothing gets lost inside this carefully orchestrated factory. Now the production line reaches its fastest pace. Conveyor systems move hundreds of wristbands every minute as robotic arms sort them by color, size, and customer order. Barcode scanners track every batch automatically, allowing manufacturers to trace each wristband back to its raw materials. Nothing disappears, and nothing gets lost inside this carefully orchestrated factory. This is where perfection becomes the only acceptable result. Every wristband entering the quality control area carries the reputation of the factory with it. Imagine standing beside a line where powerful cameras never blink, laser scanners never get tired, and artificial intelligence checks every tiny detail faster than the human eye could ever manage. But here's what nobody tells you. Even the world's smartest machines still need human judgment. High-speed AI vision systems photograph every wristband from multiple angles in just milliseconds. The software compares each image with a perfect digital model, searching for scratches, bubbles, uneven colors, missing logos, or tiny shape changes. Some systems inspect more than 10,000 wristbands every hour, identifying defects too small for most people to notice. Bright flashes from inspection lights fill the room as conveyor belts move with perfect rhythm. Despite all this technology, one final inspection still belongs to experienced workers. Skilled hands gently flex the wristband, examine the finish, and feel for imperfections that cameras sometimes miss. Years of experience allow them to notice subtle differences in texture, flexibility, and comfort within seconds. And this is where human craftsmanship quietly outperforms artificial intelligence. Only after passing every inspection does each batch receive approval for shipment. Manufacturers often work under internationally recognized quality management systems such as ISO 9001, with production records carefully stored for full traceability. Rejection rates may stay below 2% in highly automated facilities, yet every rejected wristband represents another lesson in precision engineering. Excellence comes from refusing to accept good enough. Now every wristband has survived chemistry, heat, pressure, electronics, and some of the toughest quality tests in the industry. You might think the journey is over, but another story is waiting outside the factory walls. The numbers behind this tiny product are almost impossible to believe, and they reveal just how enormous the global wristband industry has become. This is where perfection becomes the only acceptable result. Every wristband entering the quality control area carries the reputation of the factory with it. Imagine standing beside a line where powerful cameras never blink, laser scanners never get tired, and artificial intelligence checks every tiny detail faster than the human eye could ever manage. But here's what nobody tells you. Even the world's smartest machines still need human judgment. High-speed AI vision systems photograph every wristband from multiple angles in just milliseconds. The software compares each image with a perfect digital model, searching for scratches, bubbles, uneven colors, missing logos, or tiny shape changes. Some systems inspect more than 10,000 wristbands every hour, identifying defects too small for most people to notice. Bright flashes from inspection lights fill the room as conveyor belts move with perfect rhythm. Next come laser measurement systems. Invisible laser beams measure width, thickness, and diameter with tolerances often as tight as plus or minus 0.10 millimeters, ensuring every wristband feels identical in the customer's hand. If even one measurement falls outside specification, automated air jets instantly remove that piece from the production line. The entire decision happens before you could even blink. Environmental testing pushes the materials even further. Special chambers expose wristbands to freezing temperatures below minus 30 degrees Celsius minus 22 degrees Fahrenheit and scorching heat above 70 degrees Celsius 158 degrees Fahrenheit. Others blast them with ultraviolet light, moisture, artificial sweat, and cleaning chemicals to recreate years of harsh conditions in only a few days. Most people never realize how much punishment a simple wristband survives before reaching the store. The future of wristband manufacturing is becoming smarter, faster, and more sustainable. Modern factories are introducing AI-powered inspection systems, robotic assembly lines, and eco-friendly materials made from recycled plastics and biodegradable fibers. Digital printing technology also allows fully customized wristbands to be produced in minutes, making small orders just as efficient as large ones. Many event organizers are now adopting RFID and NFC wristbands that do much more than identify visitors. These smart wristbands can handle cashless payments, grant secure access, track attendance, and even improve crowd management in real time. A simple wristband has evolved into a powerful piece of wearable technology. As technology continues to advance, wristbands will become even more durable, sustainable, and intelligent. Behind every band is a fascinating blend of engineering, automation, and innovation that most people never get to see. It's proof that even the smallest everyday products can have an extraordinary manufacturing story. Thanks for watching. If you love discovering how everyday products are made, be sure to like this video, subscribe to the channel, and turn on notifications so you never miss our next manufacturing documentary. See you in the next episode.